And welcome back. Now, as you can see today on my workbench, we do have a PCB eventually. Hooray! And it is in fact the PCB for this, which is an ATTiny85 fuse resetter. Now, we covered all this way back. I mean, it's a long time ago, video 85 I think it was, and it might be an 86, we'll see in a minute. And yeah, I built this so that we could use all 6 pins on an ATTiny85. In fact, it's that one over there running. As you can see, it's got a little LED at the top. This top LED here that's flashing ever so slowly. That's the blink program. And I think that I chose the wrong frequency for the chip when I coded this, so it's going very, very slowly. But anyway, the point is, it's running with the RST pin. So pin 1, which is GPIO 5, as a GPIO pin, not an RST pin. And we went through all this in some detail so that we could eventually use all 6 pins on the ATTiny85 as input-output pins. Although that reset pin is a very weak GPIO pin, and you normally have to use it to drive, say, a transistor or something if you want to do anything sensible like a relay. But anyway, the point is it worked, and that was great. And yeah, so having done that, I had to build this to put it back into normal RST reset mode, otherwise you couldn't upload any more code. So I built this, and that generated an awful lot of interest, and I know at least a couple of you have tried to sort of reverse engineer this from the circuit diagram and create a schematic. And to be quite honest, I was hoping somebody was going to create a PCB before me, but nobody has done yet. So voila, JLCPCB have kindly sponsored this video and have sent me these PCBs, and jolly good they are too. Now, if you can remember a few weeks ago when I first started out, well, I say designing PCBs, slinging a PCB together, I'm hoping that this one is slightly better quality. I had to measure out some of these components exactly. That's a ZIF socket. It's the same ZIF socket that fits in there. And the battery holder at the top, that was quite interesting, getting that done as well. But basically, as a PCB now, I think it works pretty well. There's one error on it. Well, in fact, there's 2 errors. One in the silk screen, which is tiny. But I basically specified a resistor wrongly, okay? And therefore the silk screen is wrong. But that's just tiny, isn't it? But there is, in fact, an error. I was just looking around for my pointer. There it is. So on the back here, I'll bring it nice and close, as close as I dare. That one there, that little pad there, should be connected to ground here, like that one is there. You can see that one just about, I think, connected to ground. This one isn't. In fact, it's not connected to anything. Now, I'd have expected the ERC checker to point that out, like you've got this going nowhere, but it didn't. I don't know why. I'll have to double check. But it's my fault. I mean, I should be more careful in doing these sort of things. But apart from that, so that's easy enough done. All I did on the one that's working down here is to scrape a bit of this solder resist away from me and just bridge it across. And on the front, I misspecified that resistor there. It says R81K. It should in fact be 10K, because that resistor takes the 12 volt supply into this LED, and 1K is basically too high for it. Well, too high a current. Okay, but apart from that, it all just well, worked like a dream. The hardest bit was remembering how to use this and that. Think, how did I do it again? So just to refresh all our memories, if we go to the monitor and bring up the actual video which I did at the time, it was this one here. There we are. That's the 6 GPIO pins on your ATTiny85. So that's the video, and I'll put a link in below this one so you can have a look at that, because that explains what this is all about and why you might want to use it. And I found it incredibly useful to be able to use all the GPIO pins on that ATTiny85, because it's only an 8-pin device anyway. So 2 of them are power, so you've only got 6 to play with. And if you want I2C and a couple of IOs and all that, this is the way to do it. Cool. So do go and have a look at that video if you're interested in this. So this is the finished device. In fact, it goes that way up. And it's a shield now, as you can see. It plugs in rather nicely to a standard Arduino Uno R3. Couple of LEDs on there. One's the power from the Arduino, and this one here controls the power from the 12 volts. And yeah, ZIF socket. In fact, it's just a different shape really to this, without all the links and everything. And whereas this plugged into the Arduino like that, this one just fits on top, and it's a joy to use, even though I say it myself. Cool. Yeah, I know. I'm not as stupid as I look. Well, let's face it, who could be? So that's it then. So that's the PCB for that. And I've spent this morning building all this up with various components. Oh, I've said the magic word again, components. Now, I've ordered the components from LCSC, these people here. So let's just have a look at what they've sent me. So here's the big long list that they sent me, and I just went to their website, typed in all the part numbers. The only thing they didn't have was the ZIF socket, but funnily enough, I found somewhere that was selling them pretty cheap. So I've ordered quite a few of those. So in fact, if you're looking around for that 14-pin ZIF socket, just give me a nudge if you can't find one, because I've got quite a few of those now. Yeah, so there we are. And they've sent me all these bags of components, which I've snaffled a couple of bits out already just to build that one. It all worked like a dream. And I think it took something like 4 days for these to arrive, so from after I ordered it. So back to the JLCPCB. How easy was it for me to do this, given that I had to write a schematic and everything? Well, as you know, I've been using two products so far, EasyEDA and KiCad, and this one was actually done in EasyEDA for no other reason than, well, initially I found it easier. Now this board, it's a 1.6mm width, so standard pretty much. You get 5 boards for $2 or 10 boards for $5, and it was easy to order as well. In fact, if we go to the JLCPCB website, I'll show you exactly what I mean. Now I'm already logged in on here, so if I just say go to my account, there we are. There's the board that we're actually looking at on the workbench. It's exactly the same. And it costs, as it says over here, $2 because I had 5 pieces, and the shipping cost me $18.28 because I chose DHL. There are other options which I have tried, but they're not bedded in yet enough for me to use as a permanent feature, so DHL is probably the best option. It took about 3 days, I think, to reach me once the board had been completed. Absolutely no problems whatsoever. So that's good. And also, if you notice up here at the top, you get $8 off your first electronics parts order at LCSC, which is great. As I say, their website is very easy to use as well. And the best thing about it is, as you saw in those bags that I had, so something like this, these are resistors. You can order something like, I think you have to order something like 10, but I've ordered 50. And it means, of course, you then don't have to order any more for absolutely ages. I mean, that's what I did also with a company like Banggood, where you order a whole gamut of stuff, and then you don't need anything else for well, some cases, years, quite frankly. So that's a really good, cost-effective way of doing it. LEDs, for example, I've ordered some LEDs in here as well somewhere. Or capacitors, capacitors here. Brilliant. I mean, how many are there? 50 again. I mean, it means I won't have to buy any of these for a long, long time. That was easy enough. And because I knew all the sizes of all the things on here, I could use the footprint from the EasyEDA editor and make sure these fitted exactly. Now you have to take your time with this a little bit. Sometimes you can get a little bit blasé about, oh yeah, that footprint will do. Well, it won't do, frankly, because if this capacitor here, for example, was a different size, it basically wouldn't fit into those 2 little tiny holes. Right, because the leads from the capacitor would actually be further apart. So you have to be a little bit careful. Also, this battery connector at the top here, I had to measure very carefully. I had to make this footprint myself, I might add. Yeah, I know, advanced stuff, eh? So the distance between this hole and this mounting hole in the middle was, well, it was slightly worrisome for me, being the first time user of this sort of footprint editor, but it works amazingly well. This just, well, as you can see on the actual fitted finished product, look, I mean, it just all worked brilliantly well. Oh yes, these switches, which came from LCSC as well, they're side switches, and I thought it'd be nice and neat to be able to switch it on and off you know, from the side of the board here on some big switch or not have a switch at all. Obviously I had to measure those to the nth degree, and they just fitted. It's just, well, I don't know how to emphasize enough how great it is if you take the time to make your PCB the correct size for all the footprints and everything. You literally just slot everything in and it works. It's just amazing. Even this buzzer that I did measure about 84 different times to make sure it did fit in there, and it's quite difficult to fit in around this area. Just slotted in. In fact, it's quite a snug fit in those holes. If you look at the holes on there, and it just literally just pushes in and stays in and won't fall out until you solder it. It's really good. Cool. Well, okay, that's nice and it's great, and it was really easy to order the stuff. But does it work? I mean, does this work? Which, well, I've sort of given the game away, really, haven't I, by telling you about the two little errors on there. My errors, I might add. But in order to prove it, there's a couple of steps we've got to take. This ATTiny85 at the moment is obviously running on there, flashing the LED from pin 1, GPIO 5, to ground. So therefore it is currently using pin 1 as a GPIO pin. Now if I want to load up a different code to that device, I'm going to have to take it out of here using my trusty IC extractor, this one here. Not brilliant, but it's better than nothing, better than using a screwdriver or something, I can tell you. Basically you put this under each end, you push them together, and then as you squeeze, the hooks go up and pull out the IC enough anyway, so you can just pick it out. So I've got to take the IC out of here, put it into here, reprogram it so that I can upload code to it, put it back into here so I can program it using the board underneath now as an ISP, so Arduino as an ISP. All this is explained in that previous video. Upload the code and then put it from here back into here again, change it to a GPIO pin, put it back into here, and it will do its business. I mean, it sounds clumsy because it probably is a bit. So the idea would be, if you are going to use pin 1 GPIO 5 as a GPIO pin on an ATTiny85, get the rest of the code running pretty much exactly as you want, so that you don't have to do all this fiddling about backwards and forwards because you've done something wrong in the code and you've got to upload it and reflash it and so forth, because it gets a little bit tedious after a while. But for a demo, we can easily do that just to prove that this all works. And by the magic of video, what I'm going to do then is take the chip out of here and put it into here so that we can reprogram the chip. And just to prove it's going to work, what I'll do, I'll change the simple little sketch on here, which is the blink sketch, to make it flash a lot faster. Upload that sketch, put it back into here, and we'll see how many times we have to do this backwards and forwards, but at least I can cut out the bits in the middle. So first things first, I'm going to whip this chip out, put it into here, and then show you how I reprogram it on here, which is basically duplicating what I did in the previous video, but it's always good to see. Right, so it's out of here into here, and there's all sort of dire warnings on this PCB, basically saying use the top 4 slots, bit of a tongue twister, and pin 1, it's marked a couple of times, is down here. So normally, of course, if you were holding it this way up, pin 1 will be up here, but no, it's upside down. Why? Because when I was designing this one, I think the orientation for a start is sort of horizontal, not vertical, and I used the bottom 4 slots. So I was designing it like that. But then I noticed if I did that on this board, the handle here would have been over here and would have fouled against the battery. So I had to turn it round and reconnect. I suppose, yes, all right, I was being a little bit lazy in my design. I should have done it so that 1 was at the top left and 5 down here and 8 there and so forth. But I didn't, all right? Culpa mea, as they say. But it's my PCB, I decided this would work well enough. So what I've done, I've squished that in there, put the handle down. In case you're not familiar with ZIF sockets, ZIF stands for zero insertion force, and it really is 0. If I flick this up without, there we are. So now the little holders, if you like, that hold the pins in here have opened up. If you can see they're open now, which means you can just literally pluck this chip out. You can see it wobbling about. So if I put that in again, and it doesn't really matter if it's left, right, center, as long as you hold it down really as you do it. As I hold that down, you can see that the little slots in there are going to shut up. There we go. So basically it clamps the legs in that socket for a good contact. Great. Now I've already got the program running on here, and if I bring up the debug window from the port that this is running on, which is 15, I hope. Yes, 15. We should see some action. So let me bring that up. Right, that's the debug window, but that's an old one, so I'm going to have to reset this. Well, I think it's an old one. That's why I didn't want to disconnect this, because once you disconnect, you've lost the connection to the port and have to start again. So I'm just going to press the reset. Ah, there we are, it is alive, good. So what it's saying is then, if you read the bottom few lines, basically it says, you can enable the reset pin as RST to allow programming. In fact, it's a little bit small, let me bring that up a bit. There we are. Or disable it to turn it into a weak GPIO pin, yes. So what we want to do, we want to be able to program this, so we want to turn it back into a reset pin. So I want to type in 1 in that at the top here. So at the top here, I want to type in 1. Hit send. The bit that's cut off down the bottom, I've got no line ending set down the bottom of that GPIO and 9600 board. Okay, so I'm going to have to use my keyboard a little bit, which is awkwardly placed over here. So I'll type in 1, there we are, and send. Oh, got to turn on the 12 volt supply first. It does tell me that. Right, that's the 12 volt on, and send. So we saw that read the fuses, but the fuse we're interested in is this H fuse here. All right, that's the bit that controls what that pin is doing. Now it was 5F. Now it's writing it as DF. So it says it's written it. Now it's reread it and goes, oh, now it is DF. Amazing. Okay, so that's it. So now I should be able to upload code to this ATTiny85 again. So I'm going to move it from here back into here and upload a sketch via that. Stand by. Right, so this is the sketch that we're doing. It's a standard Blink program. I haven't changed this one, although you can see down the bottom here what I've been playing about, loading stuff up before. So yes, I had to change, did have to change it, I lied. Instead of built-in LED, I had to obviously put 5 in here, which once again, as per my previous video, is very bad programming. You shouldn't be using magic numbers. I should have declared it as a define or something, but I didn't. So there we are. So what we're saying now is we're going to flash it, not for a second as it says over here, but that felt a lot longer than a second, didn't it, when we looked at that flash. We're going to say 1/4 of a second, right? And then off record, so it should flash pretty quick. Now we've got to set the tools up correctly on here. We're using the Arduino as the ISP, that's fair enough, but some of the parameters here have to be shown. I don't think you're going to be able to see these. Right, this is the monitor view of the tools, and you can see I've got ATTiny, well, the family selected here, of which I'm using the ATTiny85. The clock, now previously that was set, I believe, either to internal 1 megahertz or 8, I can't remember which. But no, we're going to say internal 16 megahertz. That's what it normally runs at. It's on my COM15, not 13. Just double check that. Yeah, and of course, programmer Arduino as ISP, which means what I've done previously is to, on this Arduino, that this thing at the top is plugged into, is load up a special program on here. It's part of the examples, I believe. It's called Arduino as ISP, or words very similar to that effect, and you just load it up on here, and that's it. It sort of acts as an intermediary then. And this little plug-in board that I've talked about before, this LED here slowly fades in and out. I think in real life it fades more than it is on camera because it's a bit too bright here. It's the heartbeat LED, just to show you that this thing is actually working. So that's what we're going to do. So we're going to upload to that. So let's go back to the code and say upload. And it says it's done it. Okay, well, once again, the proof is going to be in the pudding here. We won't know until we put that back into here to say I want the reset as a GPIO pin, and then back into here again and actually run it. Because at the moment, if I was to just put this LED back, nothing had happened because that reset pin is not a GPIO pin. Look, it just glows very, very weakly. If I blank that one off, it's just glowing barely, all right, because it's not a GPIO pin yet. Right, let's do that next. And once again, then we're back into the running of this program on here, and it's saying, right, turn on the 12 volt power. Let's not forget that, very important, nothing will happen. And what do we want to do? Well, we want to make it a GPIO pin, so we're going to disable the RST pin. So this time we're going to hit 2 and click send. So it's read it as DF, but it's writing 5F, it says, and lo and behold, when it rereads it, it is 5F. So now the exciting bit. I really hope this works. Right, so if I put this in here now, I'm hoping it should be flashing. Well, it flashed once. Oh, and again. Something tells me I've got the frequency of this chip totally wrong, and it probably is running at 1 megahertz internally, because it's so slow, that flash. It should be a quarter of a second. So it's probably, if I've got it wrong and it's 1 megahertz, it's actually running at, because that's what I uploaded previously for a previous demo. Then of course it's going to last 16 times as long, so it should be a quarter, so that's 4 seconds that this should be on for. Let's count it. 1, 2,000, 3,000, 4,000. Yeah, that's exactly what's happened. So it is in fact 1 megahertz. I can prove that at the end of the video. If you actually want to see this flashing correctly, I'll put it right at the end of the video just so you can see it. I'm not going to do it now. What we've proven here though is that this GPIO pin 5, which is physical pin 1 at the top here, is now driving out this power to this LED. Now remember that the output from that pin is weak, whereas a normal pin, even on the ATTiny85, can deliver about 20 milliamps. That can deliver about 2 or 3. And this is a very low power LED. It's all it needs to show you that it's working. But normally you'd use that then to drive a transistor or something if you want to, turn a relay on or something. Well, you would anyway, I suspect. Even an Arduino, you wouldn't drive a relay directly from one of its pins. You'd use a transistor or a MOSFET or something. So there we are. So what does this show us? Well, it shows us two things really. One, that this board, after a minor correction on the back there, is doing the biz. It's looking a bit more like a PCB should look like now, as I'm getting more skilled with designing things. Yes, I know, all right. I use the word skill there, sort of, advisedly. I'm getting more familiar with the design mechanisms required for EasyEDA and KiCad. I'm not hating KiCad anymore. I was, but I'm not anymore. It's like, oh, well, that works okay. Oh, that's what you do. Oh yeah, I know what to do now. And that's how it is, isn't it? Familiarity and experience. So the design for this from that schematic was okay. It was a bit of a learning curve, but as I say, it worked pretty well. The ordering system via JLCPCB was simple and straightforward, and they basically, let's go back to the website again, but you upload it. If we go to home, back to where we were, basically on this screen here, you just say, okay, I've got a board. It doesn't make a huge amount of difference if you do put in the right size or not, unless you want to do something called panelizing. So if you've got a very small PCB, say for example you designed a PCB as small as the top of this ZIF socket. I mean, it's tiny, isn't it, right? And you could fit a lot of those into 100 by 100. So you'd panelize it, you'd have lots of them all on the same board. And what JLC would do then is score between each of those boards, so you can just sort of snap them off rather than having individual boards given to you. So it's like one big board, but you snap it off. Anyway, that's not what I wanted to do for this particular shield. So back to the browser. So I said, okay, I've got a board here. I want 5 of them. I don't know what the size is because it will tell you eventually. Hit the quote now. Now these are the all the options, but frankly, you're probably going to stick to the defaults most of the time. Green is the quickest turnaround, as it's just popped up there, because if you choose any of these other colours, which I have done for other boards, which we'll be talking about in the future, you'll see it takes 2 days more. Look, okay, so green, leave it with hazel with lead. In fact, for hobbyist use, you do want it with lead. Really, you don't want any lead-free if you can avoid it. It just makes soldering a lot more difficult. Yeah, well, there's not a lot to do. Okay, so as you can see here, the cost is $2 for 5. If you want more than 5, if you want 10, it goes to $5, which frankly is still peanuts, isn't it? Then you add your Gerber files. So this expects the zipped Gerber files that you generate from EasyEDA, which is simplicity itself. And when you save all this to the cart, they'll say, okay, we'll let you know. whether it conforms to our standards, in as much that have you run the tracks too close to the pads, for example. So if you look at some of these very thin tracks on here, they're obviously far away from here because I've done it like that, but you can run them really close. In fact, if we look at the underside of that board, so for example these little tracks here, for example, have got to be a certain distance away from that pad. I think it's better on the back actually. Yeah, you see, look at this distance between the two tracks here. There's two tracks there, and they've got to be a certain distance from each other and from the pads. And each PCB manufacturer, although very similar, might have different requirements. Okay, so they'll run it through their checker and say, yeah, it's passed, or no, you've got to change something. Now, assuming it's passed, as mine did, of course, because EasyEDA tells you all this. You can put in what their minimum requirements are, and it will just tell you, you know, what you need to do. Once you've done that, you just save to cart, pay the money, and that's it. Let me see, 3-4 days later, I think I got my PCBs, and that was over a weekend as well. So I've ordered on a Thursday, and they arrived on a Monday, because I chose the DHL, which is 1828 down here. Now the other options they do, UPS, which is actually a bit more expensive. Interesting one, this, isn't it? Postlink GB registered mail. Very slow and unreliable. Well, okay, I won't use that then. And GB special airmail, unreliable. Well, actually, I have used that and it wasn't unreliable. It actually turned up 10 to 15 days. Yeah, pretty much so. I don't know why they say it's unreliable. I guess if it goes missing, you can't track it. Anyway, I use DHL. And as I say, these balls turned up, and top quality they are too. I've got absolutely no complaints with those at all. Fantastic. Right. There we are then. That just proves everything works. I'm happy with all that. It means, of course, that I don't have to use this one anymore. Right, if you want to see this working, flashing the correct frequency, I'm going to reflash it at the correct 1 megahertz now, because obviously that's what I've done in the past. Other than that, thanks for watching. See you in the next video. Oh, you're still here. Right, okay, let me reflash that, and it'll only take a few seconds because I'm going to chop all this out in the post-editing. And there we are. See, I told you it was that. So what's probably happened in the past is that I've uploaded the bootloader on here, and I've said this is a 1 megahertz. We're probably trying this out with just a battery or something, or deep sleep. I can't remember now. I've had this around for a little while. But there it is, flashing away quite merrily. So now the good news is I've got 4 of these boards to spare. So if you want one, send me an email please, and you'll find my address in the about section of my channel. I'll let you hunt for that first. Tell me why you want it, and remember I've only got 4, and I will give preference to those people in the UK, because obviously sending anything else anywhere else in the world is just A, expensive, and B, I don't know, might never get there. I don't want to waste these. I've only got 4 of these left. So if you want one and you want to build that, okay, you let me know. Now if you need a ZIF socket or a battery holder, both of which are quite difficult to find, or a buzzer, they're not hard to find, but I've got plenty of those as well, and these switches, perhaps I can do a little deal for you, just basically to cover my costs. I'm not in it to make money. After all, JLCPCB gave me the PCBs for nothing to promote their product. Excellent product it is. So the least I can do is send you a few bits to it, and we'll just work out exactly. I mean, if you've got a PayPal account, it'd be easy just to drop a couple of dollars in there to cover the costs. I say dollars, I'm talking UK now, a couple of pounds perhaps, yeah, just to see how it works. We'll see what it works out at anyway, and there's only 4 of these, so I'm hoping I don't get 50 requests, because it ain't going to work. Okay, thanks very much for watching. Great thanks for JLCPCB for creating these wonderful boards, and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.